Hi guys, welcome to the 7th week of the Intro to Android lecture. This week we'll be talking about networking. So just some announcements before we start. Our final homework assignment will be released tonight, and after this homework assignment we'll be moving to the hack challenge, which is super exciting. The hack challenge will start on the 30th, so that is after break. However, idea and team formation will start roughly a week earlier on the 25th. And we'll be helping with facilitating idea and team formation. And so what's really cool about a hack challenge is that you'll be working with students from the other active courses to build a full-fledged app. So we'll be working with students from the backend course, iOS course, and also design course. This means that the following lectures after this one, or after this week, will be optional. And we'll be covering some more advanced topics in Android development, including like notifications or maybe some architecture and stuff. But it really depends on what you guys are interested in. So we'll be having a field, or we'll be adding a field to your weekly feedback form to ask you what you want to learn more about within Android development. So this week we'll be talking about networking. In all of our homework so far, we haven't actually been using any networking. We've either been, creating hard-coded data or pushing data to our device or using data that our device already has. But because mobile apps are meant to be interacting with other apps and other users in the network, we should be implementing networking. So networking allows us to retrieve data from the internet. So if we want to retrieve, let's say, like eatery data or like transit data, instead of storing that information on our device, we should be retrieving it from a cloud somewhere where it's being updated constantly. Also, networking allows us to store data on the cloud. So in the past, we had you, store data on a user's phone, but generally that's pretty bad practice because this means that your app can grow very large in size, and you can't always guarantee that the user will have enough space on their phone. So if you store data on the cloud, this keeps our apps lightweight, and this doesn't create a lot of bulk for our app. And finally, networking allows us to share data and interact with other users. We can see this especially with like messaging apps or like live stream apps where data is constantly being sent back and forth. And the only way we can allow this interaction to happen is through networking. So normally with networking, we are actually sending HTTP requests. And there are some common request types that you should know, but the two main ones that you should absolutely know are GET and POST. So GET request is where you're retrieving data from the internet. Let's say you want some information about eateries, or you want to retrieve data from like Wikipedia. This is where you'll be making a GET request. And a POST request is where we send data back to the internet. So this might be where you're saving data before your app closes. Or maybe, you want to update data that's on a cloud, you'll be making a POST request. Some of the other HTTP requests you might see are like put, delete, head trace, options, connect, and patch. But generally, you won't be making those unless you're doing some more complex operations on your app. So normally when you make an HTTP request, there's two parts to that request. There is a header and a body. So the header normally contains metadata about the request or about the person who's making the request. So this will include timestamps. It might include authorization tokens. And this just allows the receiver to know that the person making the request is a valid person and it's not like a hacker or someone who shouldn't be making this request. This is more important if your API is like private and you want to authorize the person making the request. And the body generally contains the content of that request. It might be something like, hey, I want information about this. Can you do this? Or it might say something like, hey, this is what I have information of. Please take it from me. So the server will generally respond to this HTTP request with two different types of responses. If you make a GET request, it will return the requested information. And if you make a POST request, it'll usually give you a confirmation about whether or not that request was actually handled. So a lot of times you might make a POST request and it might send back something like, hey, that request failed, please try again. Or it might tell you something like, hey, it actually succeeded, congratulations. So to run these HTTP requests, we'll need something that allows us to either make asynchronous requests or allows us to run requests in parallel, just because networking requests can take a long time and also a lot of resources. And that is really bad for the user because we don't want the user to be hanging and just like waiting for the app to respond to all these different networking requests. And so if you were developing for Android, even like as of recently, you might have seen Asynchronous House before. But as I showed you as a sneak peek, it has been deprecated as of API 30. API 30 only came out recently within the last few months. But since we're working with modern technologies and we're working with Kotlin, we'll be teaching you how to make networking requests with coroutines. And coroutines in general, I find them to be pretty complex just because they're not only made for networking requests, they're also used for just, in general, very computationally difficult and long, like networking operations. But we'll just be going over what coroutines are at a very high level. And if you want more details on how to use coroutines for some other parts of your app, you can check out our textbook, which goes into more detail how to actually implement coroutines in different ways. So I guess like to preface the talk about coroutines, we should go over like two different types of functions. I guess the type of function that you're most familiar with are blocking functions. These are generally the type of functions that you see, like in Java coding or in object-oriented coding if you aren't dealing with threads. And this just means that if there are multiple functions running, if a function starts, it has to finish before another function runs. So in the example that we see on the screen, function A, when it starts, it has to continue running and finish before function B can even start. And the problem with this is that if function A takes a long time, then that means function B or anything after it can't do anything until function A finishes. And this means that if the user is waiting on function A, they may just be like greeted with a blank screen on their phone, and they may not be doing anything. So there might be cases where you've seen on your apps, you'll be greeted with like an app that seems to like freeze or do nothing. That's probably because there are blocking functions that are being run and the operations aren't being optimized. So if we want to optimize it, we can use suspending functions. So this means that if a function starts running, it doesn't necessarily need to finish before other functions can start running. So in this case, function A starts running, but it actually suspends itself and pauses and allows function B to run because the compiler knows that function B will run and finish a lot quicker. And once function B finishes, function A can continue running. And what is really cool about coroutines is that they actually determine what function runs first and what function should be suspended for you. So as a developer, you don't need to think too much about what order all the functions should be running in because it's all taken care of with coroutines. So here's like what coroutines may look like. I wouldn't worry about, I guess, like this code block in general because it does look very complex. I think something that you should know is like how to recognize coroutine code and like just like know roughly what it means. But this code chunk is just here to kind of show you like how all the different suspension actually works. So at a very high level, we have a RunBlocking chunk. This allows us to create a blocking function for the main thread. So this means that function main has to start running and finish running before anything else beneath it can continue running. And you'll also notice that there is a launch. Launch just allows us to create a coroutine scope. And this is sort of where we just like bunch together functions that are related to each other and make sense for them to run together. And we also have a coroutine scope. This is a suspending function. So this means that this function can start and maybe pause and then continue running again. And one thing to note is that coroutine scope is also blocking in the sense that anything beneath it is blocked from running until everything above it is finished running. So with this example, in the output, we see that the print statement on line 14 runs first, or it completes first. So actually, the launch chunk on line 2 starts running first, but you can tell that the delay is very long. It's 200 on line 3 compared to 100 on line 13. So this is why the print statement on line 14 prints first. And then because coroutine scope is a suspending function, it will allow line 4 to print afterwards because the delay is finished. So then that's where line 4 prints afterwards. And then because coroutine scope is blocking, so it can't go further down into line 17 until it prints out line 10, as you see as a third print statement. And then finally, now that everything has finished, nothing is blocked anymore, I guess like the code can continue running, and then line 17 is printed out. So that might have been a little confusing, but I would suggest that if you have time, you should look at this code block in our textbook and just sort of like wrap around and just like understand what is going on. But I would say that it was even a little bit difficult for me to understand at first as well, so I wouldn't worry too much about it. The one thing that is important to note, and it is important for networking, is dispatchers. So all coroutines run on a dispatcher, and it is important what type of dispatcher you use, because each dispatcher runs on a different thread. So there's 3 different types. There is main, IO, and default. Normally, if you're updating your state in terms of architecture, or you're running suspend or UI-related functions, you'll be using the main dispatcher. And it's important that you don't crowd this too much because you are running a lot of UI-related stuff on a main dispatcher. This is why networking requests or any like really intensive requests like file.io requests, or even like writing to a database, like those type of requests are all done on the IO dispatcher. And then just generally any intensive operations like parsing a list or sorting a list, you will put it on a default dispatcher. And this way, it allows us to optimize our operating system and allows the code to run much faster. So here's an example of what it might look like if you want to use a dispatcher with networking. So at the very top, we have a suspend function called function A. This is actually running on the main dispatcher. And you'll see that we have a function called get. This is also a suspend function, but this is where we make our actual networking request. And you'll notice that when we make our actual networking request, we're actually running it on dispatcher.io. So get will run on dispatcher.io. It will finish and return a value for result. And then show result on line 4 is also running on the main dispatcher. So it just returns back to the main dispatcher. And switching different dispatcher like this allows us to optimize our code because we're just running things in parallel. And here are some popular networking libraries that you can use. I guess this is both a benefit and a fault of Android in that there is not one particular networking library that is just the default networking library for Android. Normally in the industry and also within app dev, we stick with OK HTTP and Retrofit by Square. We also use a bunch of other libraries by Square, but you don't have to use it. Although I think in a demo we'll be showing you how to use how to do networking with these libraries. You can also use Volley by Google. I think it's officially it's officially supported by Google. So there should be some documentation on it. And there's some other third-party libraries that are pretty common within just like the open source space. And yeah, so now we'll be moving on to the demo where Kevin will be showing you how to make some networking requests in the code base.
Hey guys, welcome back. This week we're going to do some networking. This is the most fun part of any kind of app because, without the internet, apps really are really bland things, aren't they? So today we're just going to start with a blank activity, and let's play around with some networking, shall we? The frameworks we'll be using are going to be the OK HTTP framework by Square, as well as Moshi by Square for now. There's also a ton of other excellent frameworks. Retrofit is a extremely popular and up-and-coming one. But in a lot of our current apps, app dev does use OKHTTP, so this is what we know, and we'll show it for you. So, I'm going to use this nice little placeholder JSON. This thing allows you to JSON placeholder is what it's called. It's an online fake API that you can connect to that will have pretty much everything a normal API would have. It has some fake posts with a bunch of lorem ipsum text. So this is the JSON it will be returning. Comments, photos, whatnot. Photos. Oh, it actually does have URLs and whatnot. Yeah, so things like that. And you can also put post request to it, put request to it, and even delete from it. Or at least it'll give you the right response. It won't actually be posting or deleting anything. Yeah. So, yeah, you've learned about all these HTTP requests in the lecture. So get request will just be getting information. Post will be putting some information on the web. Put will be putting it specifically in one place. Patch is to edit. Delete is to delete. So let's play around with it. First things first. Inside our main activity, inside our app, we're going to need some resources. So, OKHTTP is an implementation. You can find all of these online, so all of these specific URLs. But OKHTTP by Square is this URL, and these are version numbers. Mochi by Square is similar in the sense that it's that. You'll also need Mochi-Kotlin, which is their Kotlin-specific version of adapter for Mochi. It's something that you need to run Mochi as a... Let me explain what actually some of these frameworks do first. So OKHTTP is the connection framework. It is the thing that you can use to request data and put data on the web, request data from the web. It is just to send and receive data. It's doing the bulk of the work. Mochi is a framework to take any JSON wrap data and put it into a class, just automatically convert it into a class. Incredibly useful when you're working with larger data types and you have things nested inside each other. Yeah. And then finally, we're also going to need some coroutine stuff. So coroutines is what Kotlin uses for essentially extra threads. Coroutines are similar to the idea of having other threads in Kotlin. Leslie has explained more about it in the lecture. But in this sense, you can't run networking on the main UI thread in Android. That would be kind of terrible. You can't possibly, while loading, just freeze the UI until it works. Well, you can. Except that would be a terrible, terrible user experience, and therefore Android literally does not allow you to run a networking request on the UI thread, because that would be horrible. These are the commands. These are the Kotlin imports. So Coroutine's core and Coroutine's Android. I'm going to sync it now. And awesome. So, yeah, let's start by getting some simple data back. I'm going to, in here, just tell hello world that essentially it can take up as much space as it wants. I'm going to give it free reign, right? But I also have to give it a name. I'm going to give it a name, text view. And let's see if we can access text view. No. Okay. Interesting. It's happened this problem for me too, just recently. All right, we'll go the old-fashioned way and find the view by ID. So I'm going to lay in it a variable called text view, and give it a type of text view. text view equals find view by ID r.id text view. This is always the backup for when automatic r.id stuff isn't working in Kotlin. So you can always do it the Java style and find the view by ID. Let's set up a few things. One, an OK HTTP client. So let's set up a client. So private, actually, you know what? The client can even go outside of the class itself. Private value client. And I'm going to give it an OK HTTP client. Brand new. Private val. Yeah, let's stick with a client for now. Yeah, and we'll deal with Moshi later. So to make a request to the server, I'm going to set up a new value. I'm going to call it request get, because this is a get request. And we're going to talk about post requests later. I'm going to build a new request. And there we go. I want the OK HTTP version. A lot of things have something with the name request in it. And I'm going to get a URL. So what is the URL here? Posts. That is the URL you're going to hit to get the same data. So put in a string and build a request out of it. From there, all we have to do is client.new call. And then let's put the request in there. And then put it onto a queue. You can execute it immediately, but that blocks the current thread. And right now we don't have a coroutine set up, so you can't possibly do that. If you put it on a queue, however, it'll be executed sometime later, when it's possible, off the main thread. That's what we're going to be using for right now, because that's much, much easier because that's very convenient and nice for the people who use these things. It has to be a type callback, because this isn't something immediate. And you'll notice that this type is associated with OK HTTP. This is something that they've set up in their framework. And we have to implement both of these members. Okay? Done. Now, you see, here's an on failure and an on response. So if you can't send it out somehow, it'll fail. What do we do if it fails? For now, just print the stack trace. Now, what do we do if it succeeds? Well, let's use the response. So a response came back, and I want to use it. I want to check if the response, which I think in this case they called it IT by default, if it's successful, in this case, if it's not successful, I want to do something. I'm going to throw an IO exception for now. And you can just... this is probably the most helpful if you want this to show up inside your logcat. So unexpected, and then throw the response in the unexpected. If not, let's just get some of the data out of it. So text view.text is equal to response.body. Oh, right, sorry. .body .string. Now, there's an issue with the body and the fact that it might not exist, so you have to assert it. That will set the text here to whatever comes back. Let's see what actually comes back. Let's build it. And here is our virtual phone. If my recording crashes, my condolences. My computer is really running at its edge at this point. That is of 16 gigs of memory. I have no idea what's eating up so much. Crashed. And this was actually expected. Simply put, it doesn't have permission yet. Permission denied. And it'll tell you exactly why. We haven't actually asked for permission to access the internet. So now that that's in the manifest, and it's informing the operating system that, yes, in fact, as an app, I would kind of like to use the internet. There we go. That's a lot of data. However, it's also not very useful in this form. Like, what are you going to show the user? This? That's terrible. But luckily, we have something called Moshi, which is essentially a way to crush that JSON data. And instead of parsing it yourself, it'll attempt to do so automatically. So what we're going to do is we're going to create a little class. Kotlin. And I'm going to name it a post. Because that's what I believe these are. These are posts with a user, an ID, a title, and a body. So let's do exactly that, in fact. I don't want it to be like that. I want it to be something that has a value of a user ID, an int value, a value of an ID, an int value, and let's just make sure again. Int, string, string, title, body. Name them exactly what you find in your JSON, just to avoid any issues. And Moshi should take care of all the rest. I'm also going to call this a data class because that's really what it is. It's you can tag things with data in Kotlin to tell you that this is for handling data. And in this case, private value Moshi. And it's going to be Moshi dot builder. And okay, hold on. Let me import it so it's actually me. Moshi dot builder dot. Because we're in Kotlin, we have to add one more extra thing called a Kotlin JSON adapter factory from Moshi. And give that parentheses. And then we build it. Again, this is code that's provided on the net. You don't have to memorize any of this. So like find this on the internet, find how other people have implemented it, and then implement it yourself. Don't try to memorize anything in code. Languages change, frameworks change, standards change. Learning how to apply what you can find online, that never changes. Let's continue with this. And let's build a adapter for a single post for now. Private val post JSON adapter. I'm going to give it I'm going to set it equal to moshi.adapter post and the class from inside the post. Moshi takes in the raw class, not the Kotlin stuff. It wants the raw class data from Java to adapt it into something. Now the issue here is we currently have a list. And we can't just do this. That doesn't work. Neither the surrounding the whole thing. These are not valid ways of typing. However, we can build a custom type called that will handle this. So post list type. I'm going to get types from Mochi because Mochi has its own type system. New parameterized type. And I want it to be between the list class and the post class. And now we can build an adapter for more than just that single type to handle a whole list. Now, it's a little upset right now because it actually doesn't. Kotlin needs to be able to infer types, and right now it's unable to. So I'm going to give it the direct type. It's a JSON adapter of a list of a post. Now it's happy with me. So what we can do here is rather than getting the text here, we can go one step further. We can get value, set it, call it posts, and let's get all the posts. Let's get a list of posts out of that. Out of that response. So I want the adapter for it. I want to get something from a JSON, and I want to get it from the response dot, and I want the body. Make sure it is from the body and just raw source. That will get me actually a list of all the posts in this nice little post format. So if I do posts dot, and then we get all the list values. So I'm just gonna get the first thing in the list. And I want the body of it. And, I'm going to say it probably has a first thing in the body. You might want to do some checks beforehand if you're more uncertain. And in this case, I'm still going to just use text view and set it this way. If it was something more advanced, of course, we do something along the lines of, well, let's make a recycler view that will adapt things from the posts. And I might do that towards the end. But for now, let's just see. What is in the first body should be... wow. Whatever that is. Hey! And it even converted the /ns over into new lines. How nice of them. So, ta-da! And we've done this many times before where you've just taken a list of things and put it into a recycler adapter and tossed it onto the screen. So I'm, for now, just not going to run over it again. Let's do something a little different, per se. How about rather than getting something, we put something onto the internet? Well, that would be done in maybe a slightly different way, wouldn't it? Let me instead, you know what? Let's keep this text here, and I'm just going to put a button down somewhere. Onto the center of the screen you go. Tie you to both ends. To the top and to the bottom. This is a button that is called button, so I shall not tinker with it much. You are now known as button. Of type button, of house button, r.id dot the button. So button dot on set on click listener. And let's say that I want to post something. In this sense, I want to post to this same URL. And in fact, there is a post endpoint called posts to put something online. Lovely. From there, we have to tell it to post something. So post something inside with a request body. For that, I'm going to actually need a sample post to work with. And I want it to be of, oh, that's not what I wanted. Post. In here, let's say ID of 0, user ID of 0, so I'm the root user or something. The post ID is over 9,000. That's an old me. Let's see how many of you get that. The title of it is Hello World. And the body of it is, let's just throw something random in there. So for the sample post, how do we get it from, say, the object that we've created in here? Well, we can use the adapters again from Moshi. In this case, we're not using the multiple post adapter. We're using the singular one that we've made with just a single post class. And I want to do to JSON. Yeah, I want to turn it into a JSON. So I'm going to give it the sample post. Let's go to a new line, shall we? Hold on. Let's go to a new line, shall we? And you see, it's still not happy because it's only a string right now, and this thing wants a response body. Luckily, toResponseBody is a lovely built-in method in OKHTTP, and that should do it. And we'll build this new request. Similarly, client.new call, and I want to post something online. And when you post something, you want it to happen now. You don't want it to happen sometime later. You want it now. I want to execute this request. And so, and whenever it executes, and it will execute, let's do the exact same thing. Like if it's successful, let's do that. Not response. Hit. How did it even parse before? That's curious. And if it fails, if it fails, it'll throw an exception. If it succeeds, we'll set the text to whatever's in the body. Heads up, when you call something from the body like this, you can only do it once. You can only get things out of the body like this one time. So when you do, you better get all of the data out and into the frameworks you want. And let's give this a run. Terminate. Pop it open. We've got data back. Let's use the button. Crash. Now, why do you think this is so? Precisely. So I talked about this before. Executing means it's happening right then and there on the thread. And in this case, set on click listener, this is still happening in the UI thread. This is damaging. You can't network on the UI thread. You are not allowed to network on the UI thread. So let's move this somewhere else. Let's make a private function post something. And let's put it in here instead. Everything still works, everything's still fine, everything's still here. Lovely. Now, what we're going to do here is we're going to play around with some coroutine stuff. So, run blocking is a coroutine block that will anything in this code is blocking. So runs everything in this code first, then continues on. Essentially, it's a lot like running on the main thread, except you're still inside what's called a coroutine scope. This is inside a coroutine. However, you can also do something like coroutine scope and put this onto a scope that inherits from the previous one. Or you can launch something, which let me get the details from when it says so. It launches a new coroutine without blocking the current thread and returns a reference back. You can cancel this as well. So if I put launch, I can now put post something in there, and this should run without blocking the main thread. But it still does. Because your launch, this is all still, actually launch I think might inherit something that is still on the main thread. Let me just show you the right way to do it, because I have trouble explaining coroutines, because they are complicated even for seasoned Android developers. This is an I/O event, so I'm going to send it out with a coroutine context from the I/O side. This is something that is designed for asynchronous operation, so you send it through dispatchers.io. And in here, if I post something now, this will be running it with a coroutine context. Given this will be running something with a coroutine context of dispatcher of I/O. So this will be something designed for a non-blocking operation that might take some time. You can only do with context inside a coroutine scope, however, so that doesn't belong there. Whoops. Control Z. There we go. So this should run it just fine. And now we have a response back from the server that it did go through, it didn't fail, and there was an I/O exception, and that we posted this new data online. Not bad, isn't it? So like this, you can just, you can now download data, put it into your app, and also put data back online where you need to. There's also a few other things I'd like to quickly touch upon. Like the URL request builder actually has a lot of different things. So in here, you'll also see adding headers, setting header values. These are important for when you want to do some authentication things. A lot of authentication systems will put data in the header, not the body. So inside the header of the HTTP request, they'll put in some stuff about authentication, the current session, maybe what's encrypted with, things like that. That often goes in the header. You can also tag things, cache control, and like in with OKHTTP, you can do a lot of crazy things like stream data to something. If it's a big thing, you can send a file. You can request data as a stream. It's a quite well-built and incredibly complex system that interweaves with the most complex thing you can really interact with, the World Wide Web. So, yeah, that was simple networking. This is by no means the best way to implement something like this. You'll see that actually it's open source. And let me open up the course grab application in this window. And you'll notice that we have essentially parsed it out to something a bit more complex. We have an endpoint in here that will do an OK HTTP request, but it builds that request in different ways depending on the sessions we're using. So we build that request body in a similar way to request body, whatnot. And then we'll use the request builder here to add endpoints, headers, whatnot. But as you can tell, this is a lot more complicated and set up with a lot more things. We're only using gets and puts in our fancy course grab apps. So really, that's a lot of the stuff you need. Gets and posts, sorry. Yeah. Yeah, often in the industry, you're going to move out a lot of these more repetitive pieces of code and put them into different places. And reuse similar requests and whatnot. So, don't take the demo as gospel of what industry does, but it's a pretty good demonstration of how simple networking works, that you can't put it on the main thread, that you need to send it some data, and then you need to put it inside models that you have in your system, such as these. Models are very simple, they're nice and small, and act as an excellent data storage object as an intermediary between raw JSON and what your UI should display. All right. I believe that to be the end of the lecture. Good luck on the homework this week, and we'll see you next week with some guest lectures by some other members of the Cornell App Dev Android team.